Let's look at belts tutorial. So for question 1, it says that a belt drive consists of 2 V-belts. So this is very important. So we have 2 V-belts in parallel groove pulleys which have the same diameter. So same size means same diameter. The angle of the groove is 30 degrees. The cross-sectional area is given as 750 mm squared. The coefficient of friction is given as 0.12. The density of the belt material is given as 1200 kg per meter cubed. The maximum safe stress is given as 700 megapascal. So what we are to do is we are to calculate the power that can be transmitted between the pulleys of diameter 300 mm when it is rotating at 1500 revolutions per minute. So that's first part, and the second part is the shaft speed at which power transmitted would be maximum. Keep in mind that we need to take into account the effect of centrifugal tension while solving this problem. So we've got V-belt analysis, we've got a V-belt, so we'll use V-belt analysis. So 2 belts, dimensions, coefficient of friction and everything is given. So let's proceed with the solution. So what happens is this 30 degrees is the angle that is given. So 2 times beta is given as 30 degrees. So the included angle is 30 degrees, and we know that in our calculation we will use beta. So 2 beta is given as 30 degrees. So this is something that you need to remember. The angle that is given is not beta, but it is 2 beta. The cross-sectional area is given as 750 mm squared. Coefficient of friction and all these variables are as such. So the first thing is that the rotational speed is given as 1500 revolutions per minute. We can calculate the velocity of the belt. So velocity is given as pi dn upon 60. So pi, substituting for diameter of 0.3 meters, we get a linear velocity of 23.56 meter per second. The maximum safe stress is given as 7 megapascal. So let's start solving this problem. So the mass of the belt is given as density times the volume. So density times the cross-sectional area times the length of the belt. Density is 1200. The cross-sectional area of the belt was given as 750 mm squared. So converting 750 mm squared to meter squared, we just simply multiply by 10 to the power negative 6. We take the length of the belt as 1 meter. So per length, so we take the length of the belt as 1 meter. So the mass of the belt then equates to 0.9 kg. The centrifugal tension is given as mv squared. So mass is 0.9. The linear velocity we had already calculated as 26.56. So substituting it over here, we get our centrifugal tension to be simply 499.57 Newton. The maximum tension is simply given as sigma times the cross-sectional area. Your stress was given as 7 megapascal. The cross-sectional area is 750 mm squared, converting it to meters. So we get our maximum tension in the belt to be 5250 newtons. Now the next thing is that this is something that we had discovered or derived in our lectures. So what happens is the maximum tension is nothing but equal to the total tension on your tight side, which is TT1, which is simply equals to T1 plus TC. So now what happens is we know a maximum tension, which is same as the total tension in the tight side, which is 5250, which is equals to T1 plus TC. TC we know it's 499.57. So therefore T1 is nothing but 4750.43 newtons. So we have got our T1. The next thing is we can find T2 using our tension ratio. So for V belts, the tension ratio is given as such. So T1 over T2 is equals to exponential mu theta over sine beta. So what happens is, so what we have is the coefficient of friction was given as 0.12. Now what happens is the rep angle, as to why I've used pi is basically, it says that in the question that both the pulleys have the same diameter. So this is how the system would look like. So once you have the same diameter, so you'll see that the rep angle over here is basically 180 degrees. So the rep angle over here is 180 degrees. So to convert that 180 degrees to radians, it is 180 over 180 times pi. So you simply get pi as your rep angle in radians divided by sine 15, because what happens is the included angle, which is 30 degrees, it's 2 beta. So beta is simply 30 divided by 2, which is 15. So once you carry out this tension ratio, you get that T1 over T2 is nothing but equal to 4.29. So we had already calculated T1. So T2 is nothing but T1 over your tension ratio. So therefore your T2 equates to 1107.33 newtons. Finally, what happens is the power is simply equals to T1 minus T2 times the velocity of the belt. So T1 was given as 4750.43 minus T2, substitute it over here, times your velocity, which was 23.56. So we get the power transmitted to be 85.83 kilowatt. But what happens is in the question, what we have is we've got two bells. So it says that we've got two bells, and what happens is both the pulleys are of the same size, so indicating that same diameter. So what happens is with respect to two pulleys having same diameter, the rep angle or the rep angle is basically 180 degrees. So we got pi as our rep angle in radians. And then what happens is, since we've got two V belts, so the power will be doubled. So basically the power transmitted by this V belt drive system is simply equals to 171.67 kilowatt. Now what happens is, it says that you have to calculate the speed for maximum power transmission. So to calculate the velocity for maximum power transmission, we use this formula, which says that your velocity is nothing but square root of T over 3m. The maximum tension was given as 5250. We calculated it. The mass of the belt was 0.9. So what we do is we get our velocity to be 44.09 meter per second. And then what happens is, the question says we have to find the speed, not the velocity at which the belt needs to be operated. So what we know is that your velocity is pi dn upon 60, making n the subjective formula. We get that the speed at which the pulley should be rotated is 2807 revolutions per minute. So at this speed, the power transmission is going to be maximum. So moving on to question 2. In question 2, what it says is the pulley used to transmit power by means of ropes, and the pulley has a diameter of 3.6 meters. In total, there are 15 grooves on the pulley, and the groove angle on the pulley is 45 degrees. The angle of contact is given as 170 degrees. Coefficient of friction between the pulley and the rope is given as 0.28. The maximum possible tension in the rope is 960 Newton. The mass of the rope is given as 1.5 kg per meter length. We have to determine the speed of the pulley in revolutions per minute and the power transmitted if the condition for maximum power prevails. So this example is looking at, also this question is looking at maximum power transmission condition. So keep that in mind. And also we need to take into account the effect of centrifugal tension in this problem. So what we do is we just list the values of the variables that are given to us. So the angle on the groove is given as 45 degrees. So 2 beta is equals to 45 degrees. Coefficient of friction is given as 0.28. The diameter of the pulley is 3.6 meters. The mass of the belt per length is given as 1.5 kg per meter. The maximum tension, which is basically your capital T, is given as 960. Angle of contact is 170 degrees. Converting it to radians, you get 2.97 radians. So the first thing is, we know that in this case we're looking at maximum power transmission condition. So with respect to our lecture notes, we said that for maximum power transmission condition, your centrifugal tension TC is nothing but your maximum tension divided by 3, or 1/3 your maximum tension. So your maximum tension was 960 divided by 3, you get your TC to be 320 Newton. Now again in your lecture notes, we said that your maximum tension is nothing but equal to the total tension on the tight side. So your maximum tension simply is equals to TT1, which is the total tension on your tight side, which is equals to T1 plus TC. So what happens is, TT1 is 960, T1 we don't know, and we know that TC is 320, which is basically 1/3 your maximum tension. So therefore, when you make T1 the subject of the formula, your tension on the tight side is given as 640. We can find our tension ratio. So T1 over T2 is equals to exponential mu theta over sine beta. So substituting for these values, so mu was 0.28. Your lap angle in radians was 2.97. Beta is 45 divided by 2, which is 22.5. So once you evaluate that, you get your tension ratio T1 over T2 as 8.7. Now what happens is T1 over T2 is 8.79. So therefore T2 is nothing but T1, which is 640 divided by 8.79. You get your T2 to be 72.81 Newton. Moving on, we have to calculate the power. So power is nothing but T1 minus T2 times your velocity. In this case, again we're looking at maximum power transmission condition. So for maximum power transmission condition, the velocity is simply given as square root of T over 3m. T is your maximum tension. The mass of the belt was given as 1.5. So substitute for these values in this equation, we get our velocity for maximum power transmission to be 14.61 meter per second. So substitute T1 and T2 as such, multiplying it by the velocity, we get the power transmitted as 8.29 kilowatt. But again, going back to the question, it says that the pulley has 15 grooves. So 15 grooves basically means that you will have 15 ropes attached to this pulley. So therefore the power is simply the power, total power that is transmitted is the number of grooves times the power transmitted by just one rope. So 15 times 8.29. So the total power transmitted by this pulley system is 124.35 kilowatt. Now what most of you will be thinking that a V-belt is not given as to why we have used this method of solving this problem, which is similar to V-belts. So you need to understand that it is again given in our lecture notes that for ropes, for fiber ropes or for rope drive system, the analysis is similar to a V-belt. So for that reason we are using this equation over here. So keep that in mind while solving this problem.